often with the arrays for two-step experiments, so when we throw a die twice or select two letters, we can list all the outcomes in an array. So that will give us all the outcomes. So today we're going to use a different way of listing outcome, is to use a tree diagram. Okay, you learned that last year. Let's recap what that means. So we're going to look at this particular example. There are two boxes. Box A and B contain 4 counters each. Box A contains 2 red, 2 green. Box B contains 1 red, 3 green. A box is chosen at random, then a single counter is selected. So you do 2 things: select the box, then select the counter from that box you selected. Okay, so before we answer the probability question, is to list all the outcomes. So how do I list the outcomes? So you got a box A, a box B, isn't it? Right? And each of these has got 4 counters. Box A has got 2 red and 2 green. And the box B contains how many red? 1 red, 3 green. And you can list the outcomes as AR, AR, AG, AG. So all the outcomes can be listed by using the tree. Okay, and the question is how many outcomes altogether? 8. Okay, good. So let me see. There's 8. Yeah. So to answer this question, you can do probability of selecting a red counter from box A. So you have to be how many are box A and red, these 2, right? So what do? You do 2 out of 8, which is a quarter, right? Okay, now that's a long way of listing the outcomes. A faster way to list the outcome is to list it as a proper. So this is called a tree diagram, which you just list the outcome, a tree diagram. There's another type of diagram, is called a probability tree diagram, which is slightly different. Probability tree diagram, which I'm going to show you how to do it underneath this in this diagram. So in a probability tree diagram, it is more simplified. I don't have to list all the outcomes. Okay, so how does that work? So we're going to write this. You still have box A and box B, but the extra thing you have to add is the probability. That's why it's called probability tree diagram. So there's 1 in 2 chance you're going to get A, 1 in 2 chance you select a box B. And then after you select A, it can only be 2 outcomes instead of 4. So there's red and there's green. And on top of that, you write down your chance. So what's your chance of getting a red? There are 2 out of 4. Get it? So instead of drawing 2 lines, 2 red, I write 2 over 4 to represent these 2 lines. So imagine if there are 5 red, you have to draw 5 lines. That would take too long. So you write 2 out of 4, and the other one you write 2 out of 4. Okay? And then the other possibility could be a red here, green there. But for a blue box, for the B blocks, you will have 1 in 4 chance getting a red, but 3 in 4 chance getting a green. So this is a probability tree diagram. You write down the probability of each stage. So that means if I want to do question A differently, all I have to do to get a red from a box A, you do half times 2 over 4. So you do half times 2 over 4. And you get the same thing, a quarter, isn't it? So you times them together to get AR, AG, BR, BG, right? So to get each outcome, you just times the probability together, okay? Right, let's look at the next one. What's the probability of getting a red counter from box B. Alright, red counter box B will be BR, isn't it? So you write probability of R BR. What's BR? BR is this one. So you have to multiply half by a quarter. So you do half times a quarter, and that's a 1/8. Can you see it's faster than listing all the arrows? You just do this, okay? All right. And then I think that's the same question, isn't it? Yeah. All right. Anyway, just skip the D, and then we're going to do. Okay. How about E? What's the probability of selecting a red counter? A red counter could be AR or BR, isn't it? Well, you will add them together, so you do probability of AR plus the probability of BR, right? So, and because they're mutually exclusive, that's why I don't minus the probability both occurring, because they can't both occur. So, therefore, you go AR is a half times 2/4 plus a half times 1/4, yep, which is 2 out of 8 plus 1 out of 8, which is 3 out of 8. Right, get the idea? Yep, this is probability tree diagram. Okay, note how it works, because you'll be tested to draw this in an exam. We've got one more page to go through, then you can start the exercise. Okay, next page. Example 2. Okay, example 2. Going to get a student to read. You want to read? All right, Jaden, go.
A bag contains 5 blue and 3 white marbles. 2 marbles are selected without replacement. Draw a free tick diagram showing all outcomes and probabilities.
Okay, good. Thank you. All right, thank you. All right. Okay, so we've got a bag contains 5 blue, 3 white. 2 marbles are selected without replacement. Okay, let's look at this. They can select your first selection. Selection can be either blue or white. But this time it's not half and half. It's 5 out of 8 for blue, 3 out of 8 for white, because 5 plus 3 equals to 8. Right? So you write down 5 out of 8 and 3 out of 8, respectively. Now, once you select the first one, because it says without replacement, if you take a B out, your chance of getting a B will be different. So your second selection will be either blue or white, but altogether, because you took 1 marble out, there's only 7 left, isn't it? And out of the 7 marbles, because you took a blue out, how many blues left?
4.
So it'll be 4. While there's still 3 white left. And the idea, so that's when they are without replacement. Okay, without replacement. Okay. How about you select a white out? It can also be blue or white, but your chance of getting a blue will now be 5 out of 7. Because there are now 5 blue, 2 white. So that's what happened when there's a without replacement. These will change. If it's without replacement, means you don't put it back. All right, once you draw this, then calculating the probability of each question will be now easier. Find the probability of selecting a marble, a blue marble followed by a white marble. So strictly speaking, it has to be B, then W. Okay? Now BW, there's only one way, 5 out of 8 multiplied by 3 out of 7. So I'm going to use this pen. So 5 out of 8 times by, oops, 3 out of 8. Oh, you can move things. Okay, let's close that. Maybe not this pen. Why does it work? Okay, this one. Oh, if you draw a circle, it goes like this. Okay. this one, this one. Okay, just times these two together. Actually, yeah, it's supposed to disappear. Okay, good, it disappears. Okay, good. All right, so now what you do is you're going to work out what this is. Let's work it out. So what would that be? 3 times 5 is 15 out of 4 times. What's 8 times 7? 56. Yep, thank you. Right. Any question? Yep. First laptop, please. Yep. Thank you. All right, 2 marbles. 2 blue marbles will be BB, right? Now BB is this times that. 5 out of 8 times 4 out of 7. 5 out of 8 times 4 out of 7. Now what will happen to the 8 and 4? They get cancelled. So you can simplify before you multiply. So if you do that, that will be 5 by, that's 1. 5 times 5 over 14. Okay, good. Okay, good. How about the next one? Exactly 1 blue marble. So that means you could have blue W or W blue. Again, because they are mutually exclusive, you can't have both at the same time. You can go BW plus WB, right? So what's BW? I think we calculated BW to be 15 over 56. We haven't calculated WB. WB is 3 over 8 times 5 out of 7, which is also 15 over 56. So if you add them together, you just get something. You get 15 over 28. All right, we're done. For without replacement means you don't put it back. Okay, write it down. Okay, after you write it down, we're going to do it. We're going to do it for a situation where it involves with replacement, which means we're going to put it back after we take it out. So if the experiment is repeated with replacement, find the answer to part B again. So we got B and B, W, W, B, W, like that. But because it's replacement, your chance don't change. So you take the blue out, or you put the blue back, so you still got 5 out of 8. Note that there's no change. And this is 3 out of 7, 3 out of 8. And this is 3 out of 8, 5 out of 8. Yeah, like that. Once you fill this out, we can now find the probability of BW. The probability of BW is 5 out of 8 times 3 out of 8. You will get 15 out of 64. So you get a slightly different answer. Which one's bigger? Well, you can tell very quickly because they have the same numerator. Therefore, which one's bigger? The one in part, the previous one or this one? The previous one, right? Because have a smaller denominator. Okay. So that means this is more likely to have a BW. If you have a without replacement than with replacement. Okay. All right. Good. Let's do two blue marbles. BB. So you get 5 out of 8 times 5 out of 8. 25 over 64. 2 blue. And exactly 1 blue marbles, you go BW or WB. Oops. WB, which is equal to BW plus WB. And then what do? You go BW is 15 out of 64. The other one, you still get WB is 3 times 5 over 8 times 5 over 8. You still get 15 over 64, so you get 30. You'll get So if you simplify that, you get 15 over 32. All right, 15 over 32. All right, all finished. So now you know how a tree diagram works, how a probability tree diagram works, how to do it when they are without replacement, well, how to do it with replacement, and the effect on the probability. Okay, all right, good. So you can start the exercise today on